Well, good day. Welcome to the second semester. Here's our first lesson for trigonometry. And we're going to start off with 2.02 Learn on measuring angles. To start off, there are exactly two ways to measure angles. The first way is measuring angles in degrees. This is what we are familiar with. We know this from algebra and geometry, probably even elementary school with protractors and so forth. We know about measuring angles with degrees. And the other thing is radians. Radians are real numbers, all right? And we'll see how they work in just a moment and quite a bit in this chapter. A big key to getting really good at trigonometry is that you really need to understand radians and begin to think of angles in terms of radians rather than degrees, because we deal with trigonometry. We're going to create functions, and functions are always functions of real numbers, not a measurement that has a unit. And so it's a little kind of strange right now, but you'll kind of see how it works as we go on throughout this semester. All right. So what are degrees? Where'd they come from? Well, a long time ago, essentially the Babylonian era, when the Babylonians were sort of in charge of the world and the most advanced civilization on Earth, they began, and many other populations as well, many of them began to study how the Earth moved around the sun and those kinds of things. And they began to realize that a year had 365 days. And since things moved around in what they assumed to be a circle, they then decided to divide that circle up into the number of days of a year. And quite cleverly, actually, they didn't divide it into 365 units. They ended up dividing that circle into 360 units. Now, why'd they end up choosing 360? Mostly because it's very close to 365, and so the circle would represent the whole revolution. The other thing is that the number 360, it's divisible by 2 and 3 and 4 and 5 and 6 and 45 and 60 and 90 and 180. Lots of numbers go into 360. It's a really, really nice number. And so once they divided that circle up, they took essentially 1/360th of the circle, which would represent to them 1 day. 1/360th of the circle was equal to 1 degree. And that's how we got degrees. Now, when you and I write degrees, we write degrees like this. We put 1 degree, or 45 degrees, or anything like that. We can do that. Now, you and I mostly have dealt with degrees in terms of them being whole numbers. So the key on this chapter is you're going to do degrees and deal with them as decimals. And again, based on time, the ancients took the degrees and they divided them into 60 minutes. And then what are called 60 seconds beyond that. And so you can write a degree like this. You can say 32 degrees, 15 minutes, and 20 seconds. And so you get this sort of notation. The 1 apostrophe means minute, and then 2 apostrophes means seconds. And so we can write degrees in this format. Now, you and I, we've done a lot of math before, and we would experience, we might write something like 44.3 degrees, and we would write it as a decimal. Okay? And so this would be a decimal, and this would be a degree notation in terms of minutes and seconds. Okay? And so what we want to be able to do is we want to be able to equate those things together. And so a minute is 1/60th of a degree. And a second is 1/60th of a minute, which means it's 1/3600 of a degree, or 60 times 60. Okay? So, degrees. This is sort of the general format. Let me show you a couple little problems you can do with this. So, the typical kind of problem that we have is that we want to take 44.3 degrees and we want to convert it to degrees, minutes, and seconds notation. And so how do we do that? Well, we use this information, all right? And so we're going to do it this way. And so the way you do that is you want to find what 3/10 here, what decimal of 60, and that gives you the number of minutes. So let me show you. So what we know is that we have 44 degrees. We don't need to convert that. So what we're going to add to this is we're going to take 3/10 of 60. Now why 60? 60 because a minute is 1/60th of a degree. So let me show you how this works. Okay. You have to do this. I'm sorry. You have to. I'm a little rusty doing our first lesson here. You have to do this by doing what is called. It escapes me. Dimensional analysis. So what we have here is we have 0.3 degrees, right? But what we want is we want to convert it to minutes. So that means we need to multiply by something that has a minute per degree. A minute per degree. Why do we want to do that in dimensional analysis? Because then the degrees cancel and we are left with the minutes. So this is typical dimensional analysis. All of you have taken chemistry. You did this with molar solutions and normal solutions and moles and atoms and all kinds of things. And we do the same thing all the time when we do conversions in mathematics. And so what I have here, when I say 1 minute equals 1/60th of a degree, what I am saying is this is 1 minute, 1 degree over 60 minutes. So these 1 degree equals 60 minutes. When I say 1 minute is 1/60th of a degree. So these are equal, so we can put them together as a fraction, and that fraction we call a rate. And then this rate, you can take the reciprocal of it as well. You can put 60 minutes over 1 degree. And so therefore, that's why we multiply by 60 minutes over 1 degree, or why we multiply by 60. And so then we're basically taking 3/10 of 60. When we multiply that out, 0.3 times 60 is equal to 18 minutes. And so this is equal to 44 degrees and plus 18 minutes, or 44 degrees, 18 minutes. Okay? So I wanted to show you this because your lesson, in the lesson, they don't talk about the dimensional analysis. They just show you how to do the problem. And in the end, I need you to know how to do the problem. But I want you to understand why you take the 0.3 times 60. Not 1/60th, not 1/3600th, but times 60. Okay? So let's go ahead and let's do this again for another problem a little more challenging. So here's our problem. We want to convert 31.33 degrees to degrees, minutes, and seconds. So automatically, I've got the 31. So I already know this is 31 degrees. Okay? Now, I want to take the 0.33, which is in terms of degrees, right? And I want to multiply that times minute over degree. And I just showed you that we multiply by 60 minutes for every degree. And if we do that, we get 0.33 times 60. Sorry, I'm snagging my calculator. So you're going to use your calculator on this, and this is perfectly acceptable use of a calculator. And I get 19.8. Notice the degrees cancel, so we're just left with minutes. So I get 19.8 minutes, which means I have 31 degrees, 19 minutes, and now I need to convert the 0.8 minutes to seconds. So I take 0.8 minutes, and I'm going to multiply that. I want to convert it to seconds, which is in the numerator, and so in the denominator. And in very much the same way, there are 60 seconds for every 1 minute. And that's why we end up multiplying by 60. So you take your leftover decimal right here, and that leftover decimal gets multiplied by 60 again to convert it to seconds. And so 0.8 times 60 is equal to 48 seconds. And so our final answer will be 31 degrees, 19 minutes, 48 seconds. And that's what you do with a decimal. Now, if you'd got a decimal again here, then you just round off to the nearest second. Okay? But in general, that's how we do the problem. That's how we convert a degree to degrees, minutes, and seconds. So then we'd like to go back the other way. All right? So let's take a look at one of those problems. Here's our problem this time. We want to convert 57 degrees, 10 minutes, and 17 seconds to degrees. So how are we going to do that conversion? Well, all we need to do in this case is we're going to use the same numbers, but we're going to go in reverse, which means we use the reciprocals. And so, once again, 57 degrees, that's okay. We can just write that here, 57 degrees. And then we're going to have point, yeah, here, let me erase that really quick. Is that my eraser? No, that's my pointer. Where's my eraser? Oh, I can't find it. Oh, there it is. There it is. Found it. Ah, much better. Thank you. Alrighty. So we have 57 degrees, 10 minutes, 17 seconds, and we want to convert that to however many degrees we have. And we have 57 degrees, so the 57 is in front of the decimal point. That means the 10 minutes and 17 seconds create the decimal point. So all we need to do in this case we have 10 minutes. That means we need to multiply by something with minute in the denominator and degree in the numerator. And in the same way, for 17 seconds, we need to multiply by something that has degree in the numerator and seconds in the denominator. But this comes from our earlier definition. We know 1 degree is 60 minutes, and 1 degree is 60 times 60 seconds, or 3,600 seconds. So we basically take the 10 times 1/60th, or the 10 divided by 60, and the 17 divided by 3,600. And that gives us our decimals. And so we'll do that. And so 10 divided by 60 gives us 0.1666 ... So this is a repeating decimal. And then 17 divided by 3,600 gives us 0.04722. And that repeats like that. So what we need to do is we need to add these together. Okay? And so and that'll give us the rest of our decimals. So if you look at this, we have 0.16666, and that goes on forever. And then we have 0.04722, and that goes on forever. So as you can see, the 6 and the 2's will add together, and that'll give you repeating 8's from this point. Okay? And then the 6 and the 7, that's 13. Carry your 1. 7 and 4 is 11. Carry your 1. And we get 2. So the correct decimal is 0.213, and then we want to round off. Okay? And you can round off to any number of places, but I'm going to round off. I'm either going to write it as a repeating decimal, or I'm going to round off probably to this digit here. All right? So I'd write 0.2139 degrees. So 57.2139 degrees. Or I would write 57.2138 repeating degrees. Okay? So, or. All right? And that would be how I would write my answers. Now, most of the time, I just picked this problem randomly. Most of the time, they're not going to give you a problem with an answer like this. It'll tend to be a decimal that stops. All right? And so you're not going to have this sort of repeating decimal issue, but it's something we ought to at least talk about and mention. Okay? So when we talk about radians, the thing we need to remember is that 360 degrees is equal to 2 pi radians. So when you go all the way around a circle, that's 360 degrees, or it's 2 pi radians. Okay? Those are equivalent. Since you have those equivalencies, you can then write a couple of fractions from that. 360 over 2 pi degrees over radians, or you can write 2 pi over 360 degrees, both of which can be simplified. 180 degrees over 2 pi radians, or, 180 over pi. Apologize, grab my eraser, sorry about that. Or you can write pi over 180 degrees. Since we can write these two fractions and they're two different units, radians and degrees, these are what we call rates. And we can use rates to do conversions by doing dimensional analysis, just like we do in chemistry and physics. All right? And so, if somebody gives me something like this, and they say, oh, you have 75 degrees, how many radians is that? Well, then I need to multiply by the fraction that has degrees in the denominator. This is how I remember it. And that one is this fraction. So I multiply by pi over 180, and then that will give me 75 pi over 180. And then I simplify this a little bit. So 15 goes into both of these. So 15 goes into 75 5 times. So this is 5 pi. And 15 goes into 180 12 times. And so 75 degrees is 5 pi over 12 radians. Okay? And that's how you do that conversion. Always, whenever you have degrees, you always multiply by the pi over 180 because the degrees is in the denominator and those will cancel. And so you're just left with radians. All right? In the same way, if you start out with radians, suppose I say I have 2 pi over 3 radians, okay? Then I want to multiply by the one that has degrees in the numerator and radians in the denominator, and that is this fraction right here, 180 over pi. And so I do that. As you can see here, the pi's cancel, and so I get 360 over 3, which is equal to 120 degrees. All right? And that's the conversion process to go from radians to degrees right here and degrees to radians right here. And so this is all you need to know for the first unit. You have to be able to convert from decimal degrees to degrees, minutes, seconds, and degrees, minutes, seconds to decimal degrees, okay? And then you have to be able to go from radians to degrees, and from degrees to radians, okay? And so this is much like going from inches to feet. It's really the same thing. It's a measurement idea, and we do it by using dimensional analysis. Now, I want to show you something that takes this beyond the kind of homework you're going to do. You can do your homework now for this lesson. So make sure you do all the practice and you understand how to do them. But let me show you one more thing. All right? If you remember, this came from a circle. All right? And let me see if I can do this in the right spot. Whoops. I'm trying to grab a circle, so give me a minute. I grabbed the line. Let's try the circle. Let me see how they draw. Oh, okay. And then maybe I'll move it. I drew a square. What a numbnuts. Let me see if I can get the circle drawn. There we go. There we go. So there's our circle. So I'm going to move that circle onto our coordinate system here. There we go. So now the circle is sitting on the coordinate system. And then what we do is we label this point on the circle down here. We label it 0, 0. As you know, right behind here is the other axis. Okay, so this is 0, 0, and this is going to be 0 degrees, if you wish, because I haven't rolled the circle or anything. And then if we begin to roll the circle like this, if you think about from the center to here, this would be like 1 degree, okay? So if you unroll it, this outside part of the circle unrolls and matches up right here. Now, I know that 1 degree, right, if I multiply times pi over 180 is equal to pi over 180 radians, okay? So I know that this point here is pi over 180 as a real number, whatever that number is equal to. In fact, I can tell you what it is as a decimal, right? It's approximately 0.0175, okay? Approximately, all right? And so that's how long this little arc on the circle is. Now, if I continue unrolling all the way, say, to 90 degrees, so now I'm looking at this arc on the circle, all right? That 90 degrees will correspond to pi over 2 radians. So when I unroll this, it's going to match up out here to pi over 2, all right? And so the real numbers on the x-axis correspond to an arc on the circle. The arc on the circle corresponds to a degree or radian measure. And so we don't mark this as 90 degrees because degrees don't make sense lined out on the line, but radians do because radians are just a number. In fact, pi over 2 is 1.57 approximately, okay? And so we can continue to do this game. And we unroll the circle, mapping every point on the circle to some point on the real number line. Pretty cool, right? This is an idea called the wrapping function. And I imagine it will show up again in later lessons. But this wrapping function is really important because the key thing with the circle is I didn't have to just roll it forward. I could have rolled it backwards. And then I would have had the negative pi over 2 over here. And I would have had a lot of other things. And the circle will roll forever. So once I get to 2 pi and I've unrolled the whole circle, then I start all over again. All right? And so the wrapping function is a really cool idea. And we're going to talk more about it in the future. So I kind of wanted to end class on that and let you kind of think about this a little bit. All right? Let's talk to you later. I'm going to try and figure out how to animate this. Kind of pondering that. I'm not sure if I can do it in this program. Anyway, We'll see you later. That's your lesson for today.